Hey guys, welcome to another video on EC 202. Today we will be talking about Ohm's law and the relationship between current, voltage, and resistance. To visualize this, we will be using an online circuit simulation tool called Circuit.js. As you can see, it's already open in my browser here. If you're not familiar with Circuit.js, I recommend you click off this video and watch the tutorial video on Circuit.js. It will help you get familiar with the tool and get you up to speed. Alright, if you're still on this video, then I assume you're familiar with Circuit.js already. Now, before I get into Ohm's law, I would like to point out some things that you might see in the video that may be a bit confusing or maybe need some further clarification. Number one, the label on the wire showing the 5 milliamps and 10 volts represents the values at the junction of the positive terminal of the voltage source and the resistor. So this is the positive terminal of the voltage source and it represents the values over here. In case you are confused by Circuit.js showing voltage on a wire, the measured current and voltage are at this node right here. And to prove to you guys that it's not just the voltage on the wire, but at the node, I'm going to add a voltmeter scope. So over here, I'll put some labels, add voltmeter and scope probe. I'm just going to draw it right over here. And as you can see, it measures 10 volts. We say voltage drops across a component with resistance or a resistor by convention, whereby the voltage at the component terminal where the positive current enters is higher than the voltage at the terminal where the current exits. Now, if you didn't understand what I just said, that's totally fine. I'll explain a bit more. Voltage, as we know, is the energy that pushes the electrons to move. And when the electrons move, we call that current. As the current is about to go through some resistance, the energy that is pushing that current before it goes to that resistance will definitely be higher than the energy that is driving the current after it has gone through some resistance. So voltage goes from a higher value to a lower value, and hence we'd say it drops. I'm going to use this circuit that we have on here as an example. If I measure the voltage or the energy just before the current hits the 1K resistor, we can see over here that it's 10 volts. Now, the reason we say voltage drop is because this energy over here is going to be higher than the energy as the current is leaving that 1K resistor. And I'm just going to prove to you guys, if I put the voltmeter over here as well, you can see now that the voltmeter says 5 volts. So it went from 10 volts to 5 volts. And if you guys want to see one more example, over here it's 5 volts just before it hits another 1K resistor. And then I'm going to drag that over here after it leaves the 1K resistor. And now it's 0 volts. So we can say that the voltage has dropped across this 1K resistor from a higher value when it was over here to a lower value, and the voltage has dropped again across this other 1K resistor from 5 volts to 0 volts. That is why we say voltage drop. So without further ado, let's get right into Ohm's law. If you need a reminder of what voltage and current are, think of a current as a river. The voltage is how steep the river is, ranging from flat like a pond or straight down like a waterfall. Is how much water is passing through the river. Now let's use this analogy to answer a common question. What makes electricity so dangerous? Voltage or current? Well, the simple answer is that current kills you. But it is the voltage that makes the electrons move, which is current. So without voltage, you can't have current. For a more detailed and in-depth explanation, you can check out two very helpful videos. The first one is called Do volts or amps kill you? Voltage, current, and resistance, made by rimstar.org, and the second is called Current versus Voltage, How Much Current Can Kill You. They both do a really good job of explaining the importance of voltage, current, and resistance. Both videos will also give you a good understanding of Ohm's law and the relationship between voltage, current, and resistance. Their links should be displayed on the screen right now or posted in the description of the video. Take a look at our example circuit right here. By playing with the voltage slider on the right, we can see that the current rises and falls with the voltage, which is described by Ohm's law. And Ohm's law states the current through a conductor is proportional to the voltage across it. I'll repeat that. Ohm's law states that the current through a conductor is proportional to the voltage across it. Now, if you look carefully, you might see that the current is 1,000 times smaller than the voltage, which happens to be the value of a resistor. So you can determine that the ratio between the current and the voltage, which is 1,000, is also our resistance. And with that observation, we have found the equation for Ohm's law, commonly written as V equals to I times R. So the voltage, also called the potential difference, is equal to the current through an element times the resistance of that element. This equation is fundamental in circuit analysis because it holds regardless of the rest of the circuit. Consider this example. We're being asked to find the voltage drop across this resistor. Do not let the rest of the circuit fool you. This is just an easy task. The rest of the circuit, which I'm going to call garbage, this part can be ignored because we have the resistance of that element, which is 800 ohms. And we have the current running through the component in question, which is 15 milliamperes. So plugging the numbers into our equation, which is V is equal to I times R, where V is the voltage, I is the current, and R is the resistance, we have that the voltage drop across that resistor, across this resistor over here, is equal to the 15 milliamperes running through that resistor times its 800 ohms of resistance. Now, once we do a bit of conversion of units, we convert 15 milliamperes into normal amperes because that's the standard unit. So we divide by 1000, which gives us 0.015, and we multiply that by the resistance, which is already in its standard units, which is ohms. We get that the voltage is equal to 12 volts. And as you can see, if I highlight this resistor over here, you can see that the voltage drop across that resistor is indeed 12 volts. Now that you know how to derive the voltage, current, and resistor from a simple equation, try out this exercise for yourself. I hope this video was really helpful to you in understanding the relationship between current, resistance, and voltage, and also understanding Ohm's law and using it to perform circuit analysis. Thank you guys very much for watching, and I'll see you in the voltage dividers video.